Hello everyone, in this video we'll explore the Q-root functions. A Q-root function is a function where the variable is inside a Q-root. So this one is the parent function of the Q-root functions. And if you grab it, it's going to be something like this. A Q-root function is the inverse of a cubic function, which is y equals x cubed. It is a smooth curve that passes through the origin and increases for all of x. It is an odd function, so it is symmetric about the origin. The Q-root function and its inverse are symmetric about the line y equals x. And this one is called identity function. The domain of the Q-root function is negative infinity to positive infinity, and the range of the Q-root function is negative infinity to positive infinity. The x-intercept and y-intercept are the same because it's gonna pass the origin, right? Now here's the vertex form of the Q-root function. It's gonna be a Q-root of b times x minus h plus k. Alright, now if a greater than 0 and b greater than 0, it's going to be this direction, right? If a less than 0, b greater than 0, it's going to be this direction, right? If a greater than 0 but b less than 0, it's going to be this direction. This guy and this guy look the same, right? Now, if a less than 0, b less than 0, it's going to be this direction. And this guy looks the same, right? Now we're gonna learn how to graph a Q-root function. Step number 1, rewrite the function in the vertex form and find the vertex, which is h and k, right? Step number 2, determine the sign of a and b, and thus the direction of the function, right? Step number 3, create a table of values for additional points. Step number 4, plot points and connect the dots. Alright. Now the transformation of the Q-root function is the same thing as the transformation of the square root function, right? So if you want to review the square root function, please check out the link in the description below. Now in order to do the transformation of the Q-root function, we need to follow the order right here, b, h, a, and k. And this is the trick to help you memorize the order of transformation of the Q-root function, right? Now we're gonna start with b first, right? b represents the horizontal dilation by a factor of 1 over b. Now if b between 0 and 1, horizontal straight. If b greater than 1, it's going to be horizontal compression. Now next one, h represents the horizontal translation. H greater than 0, shift right, absolute value, h units. H less than 0, shift left, absolute value of h units. So if you look at the formula right here, and the subtraction side right here is the side of the formula. So in this situation, if h greater than 0 is shift to the right? H less than 0 is shift to the left, so keep that in mind. Now, a represents the vertical dilation by factor of absolute value of a. If a greater than 1, vertical straight. A between 0 and 1, vertical compression. And the last one, k, vertical translation. K greater than 0, shift up, absolute value of k units. K less than 0, shift down, absolute value of k units, right? Now a less than 0, the function reflects over the x-axis, right? This guy right here. And b less than 0, the function reflects over the y-axis. Now to find the inverse of a Q-root function, we're going to use the same method as finding the inverse of any function. We just swap x and y, right? And we're going to isolate y, right? Now Q-root functions and cubic functions are inverse of each other. the domain of a cube function becomes the range of its inverse and vice versa. Alright. Now let's move on to example number 1. Given the function h of s equals -2 times s plus 1 cube minus 1, we need to graph the function, right? So first we need to locate the vertex, right? The vertex should be, now rewrite this one, it's going to be -2 times s minus, right? And 1 right here becomes negative. So the vertex is h and k right here. H equals -1 and k equals -1, right? Now we're gonna let s equal 0. Substitute over here, we're gonna find y, right? So we have h of 0 is gonna be -2 times 0 plus 1 is gonna be 1 cube is gonna be 1, right? Minus 1 is gonna be -3. Now s equals -1, y equals -1. This is the vertex, right? Now s equals -2, right? Substitute over here, we have h of -2 is going to be -2 times -2 plus 1 cube minus 1, right? So it could be -2 times -1 cube is going to be -1 minus 1, right? Now simplify, it's going to be 2 minus 1 is going to be 1, right? S equals 0, y equals -3. This one is the y-intercept, which is right here. Now I'm going to change the scale of the x-axis. This is -1, this is -2, -3, -4, and -5. And this is 1, 2, 3, 4, 5. Alright, now s equals -1, y equals -1. This is the vertex, so it's going to be right here. Now s equals -2, y equals 1, so it's going to be right here. Right? Now if we graph this one, it's going to be something like this. Now question B. Determine the domain, range, x-intercept, and y-intercept. Alright, so the domain should be -infinity to +infinity, right? And the range should be -infinity to +infinity, right? Now x-intercept, we just let y equals 0, right? So let this one equal 0, right? So we're going to add 1 both sides. It's going to be -2 times s plus 1 cube equals 1. Divide both sides by -2, so s plus 1 cube equals -1/2, right? Take cube root both sides, so it could be s plus 1 equals cube root of -1/2. Subtract 1 both sides, s equals, this one is the x-intercept, right? So we can write this one in order pair. Now y-intercept, we just got it right here. It's going to be 0, -3, right? Now question C. Perform the transformation from ls equals s cubed to -2 s plus 1 cube minus 1. So we just follow the order B, H, A, K, right? Now we rewrite this one. It's going to be -2 times s minus -1 altogether cube minus 1, right? Now first we're gonna talk about the value of b. It's actually 1, right? So there is no horizontal dilation, right? Now h equals -1, right? So the function shift to the left 1 unit, right? Now next one, a equals 2. So it's going to be vertical dilation by a factor of 2, right? Specifically, this is vertical straight, right? Then you see the negative side over here, it's gonna reflect over the x-axis. Now k equals -1, right here. So the function shift down 1 unit. Now question D. We need to find the inverse of the function h of s and graph both on the xy coordinate plane. You need to swap x and y, right? So this guy becomes x and this guy becomes y, right? So we're going to add 1 both sides, right? Then we're going to divide both sides by -2. Now we're going to take cube root both sides. Then we're going to subtract 1 both sides. Now we're going to replace y with f inverse, right? This one is the final answer. Now we're going to graph these two guys on the x and y coordinate plane right here. Now the function h of s we already graphed above, right? It's going to be right here. Now next we need to draw the line y equals x. Now I need to create a table for this function. I just graph x and y. This is -2, 1 becomes 1, -2, right? This guy, -1, -1 becomes -1, -1, right? Same vertex, right? And this is 0, -3 becomes -3, 0, right? So 1, -2 is going to be right here. -1, -1 is going to be right here. -3, 0 is going to be right here. Now we're going to connect these dots so it could be something like this. We need to find the domain and range of both functions right here. So the domain and range are the same. It could be -infinity to +infinity, right? Now let's move on to example number 2. We need to graph the cube root functions right here, right? So first we need to create the table of values, right? Now the vertex is 2 and 1, right? Now we're gonna let x equal 0 to solve for y, right? So we have h of 0 is gonna be -2 cube root of -1/2 times -2 plus 1, right? Now we're going to simplify. It's going to be -2 cube root of 1 plus 1, right? So it's going to be -1, right? Let x equal 4. So we have h of 4. It's going to be -2 cube root of -1/2 times 4 minus 2 is going to be 2, right? Plus 1. Now we're going to simplify. It's going to be -2 cube root of -1 plus 1, right? So it's going to be 2 plus 1. It's going to be 3, right? Now I need to change the scale of this. Now x equals 2, y equals 1. It's going to be right here. And this is the vertex, right? X equals 0, y equals -1. This is the y-intercept, right? X equals 4, y equals 3. Now if you connect these 3 points, it's going to be something like this. Now determine the domain, range, x-intercept and y-intercept. Domain range should be the same, right? It's going to be -infinity to +infinity, right? Now x-intercept, we just let y equals 0. We solve for x, right? So we let this one equals 0, right? Alright, so we're gonna subtract 1 both sides. It's gonna be, then we're gonna divide both sides by -2. So it's gonna be, now we're gonna cube both sides. So it's gonna be, now we're gonna multiply both sides by -2. So this guy turns out to be x minus 2 equals -1/4, right? Then we're gonna add 2 both sides. So x equals 7/4, right? So the x-intercept is 7 over 4 comma 0, right? Now y-intercept we just let x equal 0, right? It's gonna be right here, -1, right? Now question C. We're gonna perform the transformation from Ls equals cube root of s to h of s, right? So we're gonna follow the order B, H, A, K, right? Now first, B equals -1/2, right? So we're gonna talk about the absolute value of B first, right? Which is 1/2, right? So because 1/2 is between 0 and 1, this one is the horizontal straight, right? By factor of 2. Now you have the negative side right here, so it's gonna reflect over the y-axis, right? H equals 2 right here, right? So because this one greater than 0, it shifts to the right 2 units, right? Now next one, A equals -2 right here. Now we talk about the absolute value of A, which is 2, right? So because 2 greater than 1, this one is vertical straight by a factor of 2, right? And you have the negative side right here. It's gonna reflect over the x-axis, right? And the last one, K equals 1, right? Right here. It's gonna shift up 1 unit, right? Now question D. We're gonna graph both functions on the x and y coordinate plane, right? So first I need to copy the function h of s, right? Down over here. Now we need to find the inverse of the function h of s, right? So I'm gonna copy the function h of s down. So in order to find the inverse function, we just swap x and y, right? So this guy becomes s equals -2. Now I'm going to subtract 1 both sides, so it could be s minus 1 equals. Now I'm going to divide both sides by -2, so it's going to be. Now I'm going to cube both sides, so it's going to be. Now this guy cube equals -8, right? So it's going to be s minus 1 cube over -8 equals y minus 2 over -2. I bring negative side down over here, right? Now I'm going to multiply both sides by -2, right? So this guy turns out to be y minus 2 equals s minus 1 cube over 4, right? Now I'm going to add 2 both sides, so it could be y equals, and I just replace y with h inverse, right? Alright, to graph this guy, we just swap x and y coordinates of 3 points right here, right? So this is 0, -1 becomes -1, 0 is going to be right here, right? This is 2, 1 becomes 1, 2, right? It's going to be right here. And this is 4, 3 becomes 3, 4, right? So it's going to be right here. And we need to sketch the line y equals s, right? So it could be something like this. Now we're going to connect these 3 points and we're going to get something like this. Now let's move on to example number 3. We're going to write the cube root function given the graph with a vertex h and k equals to 1, right? And the y-intercept 0, -1, which is s and y, right? Now we look at the graph right here, we see that it's going to be this direction, right? So either A positive, B positive, right? Or A negative, B negative, right? Now I'm going to pick the first one because it's easier for me, right? So I have the vertex form y equals A times cube root of s minus h plus k, right? So I substitute these two guys into this equation right here. So I'm going to have -1 equals a cube root of 0 minus 2 plus 1, right? Now I'm going to solve for a, subtract 1 both sides, so it could be -2 equals a cube root of negative 2, right? So it's going to be a equals negative 2 divided by cube root of negative 2, right? So it's going to be 2 over cube root of 2, right? Because this guy right here can be written as cube root of 2 times negative 1, right? And it's going to be cube root of 2 times cube root of negative 1, right? And cube root of negative 1 is negative 1, right? So it could be negative cube root of 2, right? And you have negative side right here, so it could be cancel out, right? So we only have this one, right? Now we're going to simplify this one. 2 can be written as cube root of 8, right? Divided by cube root of 2, right? So it's going to be cube root of 8 over 2, which is cube root of 4, right? So this one is the value of A, right? Substitute back over here, we have the equation y equals cube root of 4 times cube root of s minus h is equal to 2 right here plus 1, right? Now we're going to combine these two guys, so it could be cube root of 4 times s minus 2 plus 1. Now let's move on to example number 4. Example number 4 is similar to example number 3, right? We're going to write the cubic function given the vertex and the point right here. Alright, so this one is s and y, right? This one is h and k, right? And because the graph goes this way, we have a positive, b positive, right? So the vertex form is y equals a times s minus h cubed plus k, right? So substitute these two other pairs right here into this equation. We have 3 equals a times 4 minus 2 cubed minus 1, right? So it's going to be 3 equals 4 minus 2, it could be 2 cubed, it could be 8, so 8 times a minus 1, right? So we're going to add 1 both sides, it could be 8a equals 4, right? Divide both sides by 8, a equals 1/2, right? We substitute back over here, so we have equation y equals 1/2 times s minus h is equal to 2 cubed minus 1. This one is the final answer, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.